The assignment is 3.5, 3 through 53 odd. Was it all? Oh. Well, no, it's fine. Okay. If we looked at a regular quadratic equation, x squared minus 8x plus 12, does that factor? Would be x minus 6 and x minus 2. So x is 6 and 2. You understand that, right? What if I had this? X to the fourth minus 5x squared minus 36. That's kind of like a quadratic. It would be, well, we're finding the factors of negative 36 that add to be negative 5. X squared minus 9 and x squared plus 4. And then do either of those go any further? This one is x minus 3 times x plus 3. What about the other one? It does not. Why? It's a plus, not a minus. Okay? And we could do the same thing if I had x to the 6 minus 3x squared plus 2, or x to the third. That's a quadratic, only it's an x to the third. And x to the third minus 1. Well, basically, is this times this equal to that? That's what you're looking for. So x to the third times x to the third is x to the sixth. So there are some of those in the first part of your work. What if I had x squared minus 8 equals 2x? What do I need to do there? I need to write it in descending order. Would be x squared minus 2x minus 8. Now does it factor? X minus 4 and x plus 2. So let's say I had 3x to the third plus 6x squared minus 18x. What should I do? Take out a 3x. So it'd be 3x, and then you'd get x squared plus 2x minus 9. And actually, that one didn't factor, but just take 3's out. Oh, without using the box? Well, let me do one that's possible. Okay, good question. So I want to do minus 15. So this would have been a 30x. So you're used to using the box. Okay, and the box works. But what we're doing is looking for the factors of negative 15 that add to be 2. So in my head, I just do 1 and 15. Nope. 2 doesn't work. 3 and 5. That will give me a 2. Oh, 45. Sorry, that would be 45. You're right. So it would be x plus 5 and x minus 3. That's a 3. Okay. Now, I just have been doing this for decades, so I've gotten really good at it. If you need the box, go ahead and use it. And if there's a number here, you have to use the box. And the way I learned it was a lot harder than the box we just ended up guessing. Yes? An x to the third that ends up with 4 terms? Yeah, let's do one of those. Okay, looking at number... Come on. 6. So we need to put number 6 in order to start. So v to the third minus 2v squared, or minus 16v, and plus 32. Now, the only way you can factor a quadrinomial that I know of is by grouping. I group these and I group these. What does the first group have in common? V squared. So I pull out a v squared And when I pull out a v squared, what's left? V minus 2. Okay. What does the second group have in common? 16. So I'm going to pull out a plus 16, and what's left? Negative v plus 2. But that's not what I want. I need this and this to match, or this won't work. So I'll pull out a negative 16, which makes the v positive, and it makes the 2 negative. Now, most of the time, if you had a quadrinomial, this will not work. In fact, almost every time it won't work. But if you see one in the book and it says factor, then it will either work or you'll know a different method here in a little bit on how to solve them. So, what do this and this have in common? The v minus 2. So I'm going to yank out the v minus 2, and I'm left with v squared minus 16, and this actually factors. So v minus 2 times v plus 4 and v minus 4. And if it asks you the roots, they would be 2 and plus or minus 4. Does that make sense? Okay. All right. If I find a bunch of roots, let's say I had a negative 2x squared, and I find that x equals 3 and negative 4, how do I draw the graph? Well, I know that one of the roots is negative 4, and one of the roots is positive 3. Does this open up or down? Down, because the original was a negative. So something like that. There are an infinite number of correct graphs. Okay? If all you're doing is looking at the roots. So, how do we find the roots if we have an x to the third and we can't pull out, we can't do grouping. We have to do the division, and maybe we'll change this to all or odd, because I wanted to do all because I wanted you to do all those problems, but it turns out we're going to be doing the same sort of thing in the next section, so we don't need as much practice. So change it to odd. Okay. What if I had this? X to the third minus 16 x squared plus 55x plus 72. Will factor by grouping work in this case? So I could pull out an x squared from here. Can I pull out anything there? No. And grouping only works if you pull stuff out of both of them and the leftovers match. So we have to use what is called the rational root theorem. The rational root theorem gives us hints on what numbers we should guess. And the rational roots come from the factors of the constant. So this is kind of a hard one because we have 72 to deal with. So what numbers go into 72? Plus or minus 1, 2, 3, 4. Does 5 go into 72? No. 6. If 2 and 3 go into 72, then 6 will. 7 is a no. 8. 9. 10. No. 11. No. 12. 13's no. 14's no. 15's no. 16. No. 17. 18. I think 18 is actually going to work. Yeah. 18, 19, 20, 21, 22, 23, 24. I think. Yep. 25, 26, 27, 28, and 36, and 72. Ouch. those are every number that go into 72. Yeah, well, kind of. Yes, but we're going to get pretty good at making certain guesses. Okay, that's a huge list, right? Why is x equals 7 not an answer, a possible answer? 7 does not go into 72. When I factor this, I'm going to get those, and this number times this number times this number is 72. So understanding the rational root theorem is pretty easy. The constant is just the product, the multiplication of all of the factors. Okay? Now, it's really easy to tell if 1 works. Number 1. You add all the coefficients together. If you add the coefficients together and you get 0, then 1 is one of your answers. So let's do it. 1 minus 16 plus 55 plus 72 is 112. So 1 is not one of the possible answers. How do you do negative 1? You change every other sign. So the first one stays the same, 1, and then we change the sign on the second one, plus 16. We leave the next one the same, plus 55, and we change the sign on the next one, and that's 0. So negative 1 is one of the answers. That's going to help. Okay. What if negative 1 doesn't work? What do? We just start guessing. Right? So we do synthetic division, and we try, say, 4. 1, negative 16, 55, 72. And it's going to be pretty obvious if it's going to work, or at least be close. So let's see what happens when we do this. 4, negative 12, negative 48, and that's 7. So 28. 4 did not work, so we could cross that off. Okay, but I know that negative 1 works, but I want to plug in negative 1. How come? That will simplify the equation. So I'm going to type in negative 1, 1, negative 16, 55, and 72. That's 1, negative 1 times 1 is negative 1, which is negative 17, which is plus 17, which is 72, minus 72 is 0. Well, I knew that was going to happen, so why did I bother? Because my answer is a simpler equation than the original. The original equation was x to the third, so my new equation is x squared minus 17x plus 72. Do I need to do guesses again? No, because now I can factor it. So let's see if you can factor this in your head. I know they're both negative because they have to multiply to be positive 72 and add to be negative 17. Let's go through the factors of 72. 1 and 72, no. 2 and 36, no. 3 and 24, no. 5, 6, 7, and 8. Nope, sorry, 8 and 9. That's what we want. 8 and 9. So, depending on what the problem says, if it asks you to find the roots are negative 1, 8, and 9. What if it asks you to find the factors? What are the factors? X minus 8, x minus 9, and x plus 1. Does everybody understand that? I don't think so. So maybe you did. Yeah? Okay. Okay. Um, what about this one? Okay. What are the possible answers? All of the factors of 24. 1. Does 2 go into 24? 3, 4, 5, nope. 6, 7, nope. 8, yep. 9, no. 10, 11, 12. And then the last one is 24. But this one might also have fractions. Why? Nope. How do I know that this one probably has a fraction as an answer? Nope, it's the leading coefficient. This right here tells me that one of the answers is probably a fraction. Now let's think about it. This is an x to the third. So I'm going to end up with, let's call this a, b, and c. We know that a times b times c equals 24. So a, b, and c are numbers in this list. Everybody agree? But how did I end up with a 3x to the third? I have a D, an E, and an F, and D times E times F is 3. So 2 of them are probably a 1, and the other one is a 3. Does everybody get that? Are you guys confused back there? No? You're good? Okay. So if I had 3x plus 2, what's the root? Negative 2 over 3. So what that's telling me is if there's a number here, that number could create a fraction. So I have to take all of these values and divide them by 3, and those are also possible roots. But if they simplify, then I don't need to write them down because I already have them. So plus or minus 1 over 3, 2 over 3. I don't need to do 3 over 3 because I already have 3 over 3, which is 1. 4 over 3, 6 I don't need to do. 8 over 3, 12, and 24 I both don't need to do. Okay, let's test 1. Does 1 work? 3 plus 1 is 4, plus 24 is 28, minus 38 is not 0. Let's try negative 1. 3 minus 1, minus 38, minus 24, not even close. So 1 and negative 1 didn't work. I'm going to get rid of those. Let's try another one. Which one do you want to guess? So I put 2 in the box, and 3, 1, negative 38, and 24. Okay, drop the 3. 2 times 3 is 6, 7, 14, negative 24, and that's negative 48. That didn't work. All right. Let's try negative 2. Negative 6, negative 5, 10, negative 28. That didn't work. So I know the 2's didn't work. Okay. Now what do you want to try? 6? 18, 19. I don't know what that is. 114. What do you think? Not even going to be close. Okay, let's try negative 6. We could, but I don't really want to. I'll show you what you do with fractions in a minute. So negative 18, which is negative 17. 6 times 17 is going to be 102. Is that going to work? Nope. So 6, neither of the 6's worked. How about 3? 9, 10, 30, negative 8, negative 24. Got it. So 3 is one of my answers. But once you find 1, the possible remaining answers are much, much smaller. Okay? Of my original lists, which ones can I get rid of? Right. Well, not over 3. My new equation is 3x squared plus 10x minus 8. I can get rid of everything that's not a factor of 8. Because I will have 3 factors in the end. One of them is x minus 3. The 2 remaining factors multiply to be 8, because that's the new constant. So once you find 1, that will make your list smaller, unless the one you find is the number 1. Then it doesn't change anything. So I now know 24 is out. Why? It doesn't go into 8. 12 is out. What else? 6 is out. 3 is out. And I already found out that 1 and 2 don't work. So the remaining ones, oh wait, and I got to get rid of, I don't get rid of any of these. All the fractions remain. Okay? So I could continue to guess, but now I have an x squared, so I'll just factor it. But if you start with an x to the 4th, you'll have to do 1 round of guessing. Once you get that equation, then you'll do another round of guessing, and then you'll have a quadratic. But the second round of guessing is much easier than the first round. Because if you find a root, you can go through and make your list smaller. Does everybody understand that? Okay. Now, how do we factor 3x squared plus 10x minus 8? So I put in 3x squared and negative 8, and I end up with negative 24x, and I need to multiply to be negative 24 and add to be 10, 12, and negative 2. 12x and negative 2x. Why not negative, or why not 4 and 6? 4 times 6 does not make negative 24. Or, yeah, negative 24. What does the top row share? 3x, x plus 4, and 3x minus 2. So my factors are x minus 3, 3x minus 2, and x plus 4. My roots are what? 3, 2/3, and negative 4. Does that make sense? Because there was a 3 there. Yeah. Yeah, it's a lot harder to factor that in your head when there's a leading coefficient. And the way I learned it when I was in high school was such a terrible mess. The box is way easier. I wish I would have known it when I was your age. Okay, does that make sense? So, 13 says find the zeros. Okay. On number 13, we have x to the 4th, plus x to the 3rd, minus 6x squared. What are you going to do first? Pull out an x squared, and I get x squared times x squared plus 1 minus 1x minus 6. And now I just factor this, and I'm done. What are the roots for x squared? 0, and 0. It's like having 0 twice. Graphically, what does it look like when you have 0 twice? It bounces. So this graph bounces at 0, and then it has two other roots that you'll need to find. All right, and then 25 through 32, you'll find all of the zeros. Use the rational root theorem to figure out all the possible rational roots and guess until you get one of the answers right. Once you have one of them, then you can factor to find the other two. And then 33 through 37 is the same thing. In number 41, how do you write a polynomial if you know what the roots are? I know that x equals 2, negative 2, and x equals 3, and x equals 6. What are the factors? X plus 2, x minus 3, and x minus 6. So does it want me to multiply those out? So it says see example 5. 3, 4. Yes, wants us to multiply them out. So how do you multiply three binomials together? You don't. You multiply two of them and get a quadratic, and then multiply the third. Okay. 43 is a little bit hard. It says x equals negative 2 and x equals 1 plus the square root of 7. What's the other root? One plus the square root of 7 has to have a partner root. And that partner root would be 1 minus the square root of 7. Okay? So the other one is x equals 1 minus the square root of 7. This factor is easy, x plus 2. What is this factor? X minus 1 minus the square root of 7. And what's this root? X minus 1 plus the square root of 7. Multiply these together first, and most of everything will simplify down to a really easy number. And then bring this in. Okay. Does it have us completing this? Oh, shoot. Okay. What if I end up with, so let's say I have an x to the third equation, and I find out that 4 works, and I end up with x squared plus 2x minus 9. Are there factors of negative 9 that add to be 2? So what do we do when a quadratic doesn't factor? Do you guys remember? Quadratic formula. It's right there on that poster in the bottom left. Negative b plus or minus the square root of b squared minus 4ac over 2a. So negative 2 plus or minus 4 minus 4 times 1 times negative 9 is plus 36 over 2. So negative 2 plus or minus the square root of 40 over 2. And then we have to factor tree 40. 4 and 10, 2 and 2, 5 and 2. Do I have any pairs? I can bring out one set of 2's. What's left over? 2 times 5. So it's negative 2 plus or minus. I bring out a 2, and I leave the 10 on the inside. Does that simplify? Those cancel. So negative 1 plus or minus the square root of 10. Okay? So those are the roots. So x equals that and 4. The factors would be x minus 4 and x plus 1 minus root 10 and x plus 1 plus root 10. Those are the factors. So if you end up with the quadratic equation and it doesn't factor, you have to use the quadratic formula. Does that help? Is this better than it was before? Okay. So just do the odds. Don't worry about the evens. That's just too much. I don't know. I don't know why I did that. Okay. Good luck.